All right, hello there. So we're going to be going over the review for assessment number 2 and something to take note of. Remember, if you do better on this assessment than your last assessment, then it's going to replace that grade. So that should be a good incentive. If you do worse, then your other grade just stays locked in. So that will be on Thursday the 22nd, next Thursday. All right, so here we go. All right, so this graph right here, we're going to do more of this in class on Tuesday, practice this a little bit more. But for now, f of x equals x squared, we're going to plug in some numbers. So if you plug in 0 into x squared, you get 0. If you plug in 1 squared is 1. So I'm doing a little table here. Plug in 1, I get 1, so there's a 0.11. Then when I plug in 2 squared is 4. So I'm going to get the 0.24. You plug in 3, you get 9. So that's going to be a little bit up here off the graph. All right, so now when we plug in negatives, we get the exact same thing. So that's what the square does to you. It squares away any negatives. Negative 1 squared is also 1. Negative 2 squared is also 4, because it's negative 2 times negative 2. Negative 3 squared is also 9. So it creates like an exact match on the other side. So if I can draw this nice, you get a nice curvy parabola. Okay. And we're going to list on this red one what's been done to it. So I see here that the vertex has gone back 1 and up 4. So I'm going to say left 1, up 4, and I notice it's been reflected. Now notice to the ratio here. I have here it goes over 1, up 1. And so that's the same thing, right? Over 1, down 1, because it's flipped over. It goes out 2 and 4. So this is doing the same thing, over 2 and 4, and there it is. And same thing here, over 2 and 4. And if I did out 3, 1, 2, 3, and to 9, there it would be right there. So it follows the same pattern as this one does. So there's been no stretch or shrink. So I'm just going to write down the 3 things. Let's see, there's been a reflection over the x-axis. There has been a movement of left 1 and up 4. All right, so we move something left 1 and up 4. So remember back with absolute value graphs, if you move yourself left 1, you would say to yourself, oh, let me do an x plus 1. Up 4 would be a plus 4. And then reflection would be a negative. So this is basically like the same thing that's happened, except we have this new construct here of having x squared. So our equation is going to look like this. Parentheses with a square instead of the absolute value bars. I'm still going to put x plus 1 in here and then plus 4 on the outside and then put a negative in front. So it's basically the same as you learned before. It's just instead of absolute value bars, you have that parentheses with a square, because that's going to create a curvy shape instead of like the absolute value, that's a sharp turn like a V shape. Okay. All right, using this graph above, let's answer the following questions. The vertex, so that would be the spot right here, negative 1, 4. All right, the x-intercepts, so that would be negative 3, 0, and 1, 0. Don't forget those points, negative 3, 0, and 1, 0. And the y-intercept is right there, good old 3. So that's going to be 0, 3. Okay, and my end behavior. So my end behavior right here, let me mark this up a little bit. I got negative 1, 4. And then my end behavior are these arrows right here. This arrow is on the right, so that's going to positive infinity, and this is going down, so that's negative infinity. So it's going, as it goes to the right, it goes down. Okay, this one, as it goes to the left, it also goes down. So when I say left here, I'll say negative infinity, and down is also negative infinity. So the beauty of parabolas and absolute value graphs is both ends go the same way. These ends are both going down. So you should never get this wrong because they're just both pointing down. So when x is infinity, y is negative infinity. That's this piece right here. When x is negative infinity, well, y is negative infinity. All right, so basically you just kind of feel it and you're like, oh, they're both going down. Let me say negative infinity. All right, here I need domain and range. So remember the domain is the width of your graph. All right, it's how wide does it go? Well, this graph goes out for, goes left and right forever. There's no breaks or curve or like holes in it. But also I'm asking myself, what x values does it exist for? Well, let's see. 2 is right here. 3 is there. 4, I would go down there. 5, I'd go down here and the graph would meet me. So every place, even if I go to the left, 0 is right here. Negative 2, the graph would be there and meet me. So every x value this graph exists for. All right, so we're going to say negative infinity to infinity. Now, range is the height of the graph. The height of the graph is, how tall it is. And so you see when I go up here, there's nothing there. All right, when I go to 2, there's nothing there. The first place it starts to exist is at 1. And then it exists for everything down below that. So I would say that the height of this graph is going down forever, but it's only touching the top of 1. So negative infinity is the smallest and 1 is the biggest. It's touching 1, so I put a bracket. All right, and factoring. So this is a nice easy one to factor. I have the leading coefficient is 1, so I don't have to worry about any kind of GCF. So I just start factoring here. I got x and x. Things that make 24, I would say 6 and 4, 12 and 2, 8 and 3, and 24 and 1. Now, this is a negative 24, so I know my signs are going to be different. They're going to be a plus and a minus. So if I look at my list of numbers, there's 2 sets of numbers that can make 10. I can make 10 with a 6 and 4. I could also make 10 with a 12 and 2. But if I put 6 and 4, so don't write this down yet, but if I put 6 and 4 here, look what happens. Here I get 4x, here I get 6x. The only way I'm going to get positive 10 is if they're both positive. And if they're both positive, I'll never get negative 24. So I can't do that. All right, so let me erase all that stuff. So 6 and 4 aren't going to work for me. So I'm going to not use them. So I'm going to use 12 and 2. Whoopsie. All right, so 12 and 2. So this guy gives me 2x, this guy gives me 12x. 12 minus 2 is 10. So plus 12 minus 2, plus minus, and everything's working for me because I got negative 24. All right, so let's take a look at this guy. 2x squared minus 10x minus 28. So it does have a GCF, a greatest common factor. So I'm going to take out a 2, which means I'm basically dividing each part by 2. So the 2x squared becomes x squared, the 10x becomes negative 5x, and the negative 28 becomes negative 14. And now I just have a problem like I did earlier, except I leave that 2 out there. All right, so I'm going to use 7 and 2 because that makes 14 and also makes 5. So 7 and 2, and if I do a negative 7 and a plus 2, let's check it out. 2x and negative 7x. That makes negative 5, makes negative 14, so we're good to go. All right, so next page here. So some more factoring. All right, now you notice these right here in number 5 are both perfect squares. 25 and 16 don't have a GCF. This x squared and 81 don't have a GCF. These are just that little pattern we kind of showed you before where you have perfect squares. So I'm going to do letter B. That's the easier one, actually. Should have made that letter A. But I'm going to split up the x's. And remember, we think of square roots. The square root of 81 is 9. So I want to put things that are the same here because look at what's going to happen. This is 9x and this is 9x. I want those to cancel out because I don't see any x's here. I don't see 18x there. All right, I need 1 plus and 1 minus so that they cancel and go away. So 1 plus and 1 minus, and then I still get a negative 81. So same idea over here, except now I have a 25 to break up. So 25 broken up kind of evenly is 5x and 5x, like square roots. And then I put a plus 4 and a minus 4. Because that way, this is negative 20x, and this is positive 20x. Now, technically, you can put the plus and the minus either way. It doesn't really matter because everything's the same, but I just do it that way. All right, so here, factor completely. So number 6, let's see, I do have a GCF, 12 and 18. Let's see, 2 goes into both 12 and 18. 3 goes into both of them. Also, 6 goes into both of them. Let me see, 9, no. Yeah, 12 doesn't go into 18. So 6 is my greatest common factor. Also, they both have at least 3 x's. So I'm going to take out 6x to the third. And when I do that, so it's kind of like I'm dividing by 6x to the third and dividing by 6x to the third. So I think I'll write my answer a little bit lower so we can like imagine that that's happening. All right, so 6x to the third goes out here. That leaves me with a 2x because I'm subtracting my x's minus 3. And I'm done. 2x minus 3 won't factor anymore, so that's it. All right, and number 7. We are solving by factoring. So it's already in standard form. It's ready to go. I don't have to fix it. I don't notice a GCF, 5, 23, and 10, nothing in common. So I'm just going to begin factoring. This is just a factoring problem with one more step after we're done. So I put 5x and x. What makes 10? Let's see, I could use 10 and 1 or 5 and 2. I think I'm going to try 5 and 2. Now remember, if I'm going to use 5 and 2, I can't put the 5 here because 5 goes into 5. So if I'm going to use 5 and 2, I'd put the 5 here and the 2 there. Let's check that out. It's 25x. This is 2x. Yeah, I got my 23. All right, so I'm going to put those in there officially. 5 and 2. So 25 on the outside and 2 in the middle. I want the 25 to be negative and the 2 to be positive because negative 25 plus 2 would be negative 23. Okay, so I factored. So now I have to solve this. Remember that if two things multiply to 0, one of them has to be 0. Okay, so all you have to do is take these little equations, 5x plus 2, set it equal to 0, and x minus 5, set it equal to 0. So we practiced that in class a lot, so you might be able to just quickly say that x is 5 here. And if you subtract 2 over here, you get 5x equals negative 2, and divide by 5, you get negative 2/5. So you might be able to know those really quick. So my solution set with my curly brackets, negative 2/5 and 5. All right, number 8, find your inverse. So remember, f of x is another thing for y. So if I'm going to find my inverse, I switch the letters. X equals 2y minus 6. And so I start solving, add for y, add 6. So I got x plus 6 equals 2y. Now I'm going to divide everything by 2 to get rid of that. So my final answer is y equals 1/2 x plus 3. All right, so y equals 1/2 x plus 3 for my inverse. All right, because remember there is a 1 in front of the x, so I just write that 1/2 x. Or you can write it x over 2. All right, last couple problems here. I want increasing and decreasing intervals. So remember that when something's increasing, it has a positive slope. When something's decreasing, it has a negative slope to it. So if I look at this, the side of my graph that's increasing is over here. This side on the right is increasing. It has a positive slope. This side's decreasing. So I'm going to use my highlighter a little bit. The increasing and decreasing changes right here. It switches over right at the vertex there. So this whole side is increasing. This whole side over here is decreasing. Okay? So how do I name that yellow and that green part? Well, I name it using x values. Everything from 2 over is increasing, so that's from 2 to infinity is increasing. All right, and everything from 2 back, so this whole area is from 2 back to negative infinity, is decreasing. So I would say negative infinity, comma 2. You never use brackets, you always use parentheses on increasing and decreasing. All right, and that is it. And, oh, no, wait, I'm sorry. There's a whole nother problem. All right, so this one is inverses. It's kind of like this problem up here, but it's using a picture. So A, B, C, and D, I have to figure out which two of these are inverses. So let's start off by labeling some points. This is the point 0, 3. This is the point 3, 0. This is 0, negative 3. And this is negative 3, 0. All right, I think I'm starting to see something also. Also, what I can do, remember, is I can draw that line across this graph, that y equals x line. And anything that's symmetrical over this line are inverses of each other. And so I think I see something. This guy and this guy, those are reverses. If I also check another point, like let's say 7, 2, and let's go to 2, 7. There it is. All right, so it looks like B and C are inverses. Well, the same thing's happening over here with A and D. I got these 2 points, which are reverses. Then I can go to, let's say, like negative 7, 2. And over here I go to 2, negative 7. All right, so they're inverses. So those are my pairs right there. All right, so in the graph above, pick the 2 pairs of graphs that are inverses of each other, explain why. So I would say B and C are inverses. And I would also say that A and D are inverses. Because all of the points on, let's say, the first graph, or the first graphs, are reversed on the second graph, or graphs. All right, so basically what I'm trying to say there is all the points on B are reversed to get the graph of C. All the points on A are reversed to get the graph of D. Okay, so there's two pairs right there. And also you could also say something like, oh, they're symmetrical over the line y equals x. You could also mention this line right here that we drew, y equals x. All right, that's it. Good luck on your test.